This is the screencast for section 3.8, example 2. The derivative of the arctangent. Again, this is another formula that you're going to have to memorize, the derivative of inverse tangent of u, which is 1 over 1 plus u squared times the derivative of u with respect to x. But understanding where that derivative formula came from will help you memorize the derivative of arctangent. So here it is, the proof. Take a couple minutes and look over that. In example 2 here, we have an application of the derivative of inverse tangent. It says that a particle moves along the x-axis so that its position at any time t is greater than or equal to 0 is x of t equals the inverse tangent of the square root of t. What is the velocity of the particle when t equals 16? Well, as we all know, the velocity is the derivative of the position. So since x of t, or the position, is the inverse tangent of the square root of t, I'm going to find the velocity, which is the derivative. So in this case, u is square root of t. Let's see, so I'm going to do 1 over 1 plus u squared times the derivative of u. So the derivative of t to the 1/2 is 1/2 t to the negative 1/2. There can be some combination, maybe make my life a little bit simpler here. And I get 1 over the quantity 1 plus t times 2 square root t. And that's a little bit easier to plug in, 16. And I get 1/136th, and it didn't really give me units, so that could be miles per hour, feet per second, meters per minute, who knows. So it's just a distance per time. Then now try problem number 11. Says that a particle moves along the x-axis so that its position at any time t is greater than or equal to 0 is given by x of t. Find the velocity, there you go, derivative again, at the indicated value of t. So in this case, x of t is simply the inverse tangent of t. So v of t is that memorizing of the formula, straightforward, 1 over 1 plus t squared. Our u is just t, so the derivative of u is 1, which we don't need to account for in this problem. So now v of specifically 2, that the time that the problem is asking for, is 1/5, and again, that's a distance per time.